Hi, this lesson we will continue with hypothesis testing. The details of noun and alternative hypothesis, critical regions, significant level, and calculating the test statistic, please refer to my previous video. These lessons will focus on hypothesis testing for population mean, and it is a two-tier test. Now, how do we know the questions is asking about a two-tier test and what should we do about it? Let's have a look at these past year questions. The first one is the May June 2007. Last time it's called the paper 7 and now it has become paper 6 and the question 3. Okay, a machine has produced nails over a long period of time, where the length in millimeters was distributed as capital N indicates that this is a normal distribution where the mean is 22.0 and the variance is 0.19. It is believed that recently the mean length has changed. All right, to test this belief, so the belief is what? The mean length has changed. So because of this sentence, I know that we are looking at two-tier test. All right, two-tier test means the H1 is going to be the mean not equals to, right? Instead of testing whether the mean is less than or the mean is greater than. So these are the one-tier tests. So since the questions ask about testing on whether the mean length has changed, this is how we know it is a two-tier test. Okay, two-tier. Right. So to test this belief, a random sample of 8 nails is taken and the mean length is found to be 21.7. So this 21.7 is the mean from a sample, right? So this has become the sample mean. So carry out a hypothesis test at the 5% significant level to test whether the population mean has changed, right? Again, it means we are going to carry out hypothesis test, which is a two-tier test, assuming that the variance remains the same. Now, the first step, we need to define the random variable and its parameters. In the beginning, the question is telling you the length of these nails follows a normal distribution where the mean is 22 and the variance is 0.19, right? But in order for us to carry out the testings, we should be looking at the sample mean distribution, which is also going to be normal distribution. So we are looking at the mean length of these nails, which is also following normal distribution and should have the same mean, but the variance must be divided by sample size. 8 nails are taken, so divided by 8. And now we have found the variable and the parameters. Step B, define the noun and alternative hypothesis. So as the question is asking you to test whether the mean length has changed, supposedly the mean length should be 22. That is the population mean. But because we want to see whether it has changed or not, whether the mean value it is still a 22 or not. So the H1, the alternative hypothesis, is not equals to 22. All right, that's why this is called the two-tier test. Okay, now we are going to determine the critical regions. And in order for us to determine the critical region, we must have the significant level given, which is 5% here, right? So the sentence will be like this. Reject H now if, then I sketch the bell-shaped curve. So what should we do when we are going to carry out two-tier test, right? So even though the significant level is 5%, but you have to take this 5% divide by 2. So which is 0.05 divided by 2, 0.025. And this is because we are looking at it at two different ends, the two different regions, right? Left and right side. So the probability should be this. Now I'm going to scroll down to look at the normal distribution table. And we try to determine the corresponding z-score value for this 0.975. And usually you get to find out from the smaller table below. So that's why if you have a two-tier test, must take the significant level divided by 2. So the z-score should be 1.96, right? Instead of referring to the 5% straight away and taking the wrong z-score for comparison later. Okay, now we come back to the questions, which means we are going to reject the H now. If the z-score value is a 1.96 here on the left-hand side, negative 1.96. So reject z-score less than negative 1.96 or the z-score greater than 1.96. Okay, so now we have determined the critical region and continue. We try to calculate the test statistics. So the sample mean of the 8 nails is given 21.7. To minus out the population mean divided by the standard deviation, right? So 0.19 divided by 8 is the variance. So square root the whole thing, you are getting standard deviations and find out this value. Z-score value is negative 1.947. Okay, now we are comparing with the critical regions. And you can see, since the z-score value is a negative value, then we compare to these regions, right? The z-score on the left side. And we can tell that this negative 1.947, it is still greater than negative 1.96, which means it does not fall into the critical region. And that's where we can make our decisions. Do not reject H now. Right? Then we can come to the conclusion. There is insufficient evidence at 5% significant level that, so we refer back what the question wants us to test whether the population mean has changed. So this is what we want to test. And based on our calculations, we do not reject H now, then insufficient to say that the population mean has changed, means it has not changed. That the mean, the population mean has changed. All right. So we have come to the conclusions. Okay. Now I'm going to show you the next questions. Okay, so this is the questions from May, June 2013, variant 7.1 and question 2. Okay, the times taken by students to complete a task are normally distributed with standard deviations 2.4 minutes. A lecturer claims that the mean time is 17.0 minutes. So the times taken by a random sample of 5 students were, so 5 data are given. So it means this will, you have to use it for you to find out the sample mean by yourself, right? Instead of giving you like the previous questions. So you have to carry out a hypothesis test at the 5% significant level to determine whether the lecturer's claim should be accepted. Now, this sentence tells me that this is a 2-tier test. All right. Okay, let's say I jump straight to part B. H now, H1. So according to this, what are we trying to test is the lecturer's claim. And lecturer's claim that the mean, the population mean time should be 17. And that's why we are going to test whether the lecturer's claim should be accepted. So that means it's like, are we going to take the mean as 17 or not 17? All right. That is why the H1 is not equals to 17. And that makes it 2-tier test. Okay, because of not equals to is used, that is a 2-tier test. Okay, now we are going to define the random variable in step A. So the time taken should be a normal distribution, right? And according to the lecturer's claim, the mean should be 17 and standard deviation 2.4. So since this time you are given the standard deviation, must make sure put a square because the parameter is the variance that we need. Okay, but same thing when we are going to carry out testing, we are looking at the sample mean. So we are looking at the mean time taken, right? Which is also a normal distribution with the same mean of 17, but the variance must be divided by sample size. So 5 students time taken, so sample size is 5. Okay, now we have determined the variables and the parameters. So determine the critical region. Again, you must have the significant level found given by the questions. And since it's also going to be 5%, the value is the same. Like what we have found just now, again, 2-tier test must divide the significant level into 2. Then only you get to the correct z-score value. So reject if z-score less than negative 1.96 or greater than 1.96. And now we are going to calculate the test statistic. So in order for you to calculate the test statistics, these particular questions, you have to find out the sample mean by yourself. That's why we sum up these 5 students' time taken. and then find out the mean, the sample mean. Which is 18.2. So we have sample mean now, then we can continue to calculate the test statistic. (18.2) minus the claims and divided by, so since 2.4 is the standard deviation, so I just put down 2.4 and don't forget to square root the 5 and find out the value. So the z-score value 1.118. So now, since the test statistic value found is a positive value, then we are comparing with the positive region here, right hand side, and 1.118 is less than 1.96. So we have done the step, compare the test statistic with the critical region. And now we are able to make a decision. So since the z-score value is not greater than 1.96, which means it does not fall into critical region, we do not reject H0. So the conclusion, there is insufficient evidence at 5% significant level that, right, the question is asked us to test whether the lecturer's claim should be accepted. So since we have like insufficient evidence that the lecturer's claim should not be accepted. Mean should be accepted lah, right? Because I say insufficient evidence that it should not be accepted. So the lecturer's claim should be accepted, that the mean time stays at 17 minutes. All right, so these are two examples focus on hypothesis testing for the population mean, and we are looking at two-tier tests. All right, that's all for these lessons. Please subscribe to the channel and like this video. I see you in the next. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.